Okay, so this is check-in number 3. My time spent studying is still weekdays 8 p.m. to 10 p.m. And my videos watched, I started with Chapter 11, Notes 9. And it's just a Chapter 11 summary, including coordinate systems and relations between x, v, and a. Chapter 11, Example 6 was my next video. It's just a simple vector addition problem. Chapter 11, Example 7 is just using the relations between x, v, and a to solve. Chapter 11, Example 8 is just using the kinematic equations and manipulating them. Chapter 11, Example 9 is using a equals v squared over r and y equals mx plus b. Chapter 11, Example 10 is using some trig identities in order to solve for velocity in the x and the y direction, and we're just plugging those into kinematic equations. Chapter 11, Example 11 is just using the cylindrical coordinate system. It's just an example using that. Chapter 12, Note 1 is just a Chapter 11 review, as well as an introduction to the laws of motion. Chapter 12, Example 1 is just using the sum of the forces equals mass times acceleration, and we use that to find acceleration, and we plug acceleration in the kinematic equations. Chapter 12, Notes 2 is just kinetics in the normal tangent and radial transverse coordinate systems, as well as dive into free body diagrams and coupled systems. Chapter 12, Example 2 is just sum of the forces equal mass times acceleration, and we're using that along with a equals v squared over r. Homework problems completed. I finished the rest of Chapter 11, and I started work on some of the Chapter 12 problems, but I haven't finished any quite yet. Chapter 11, number 9 is a softball question. There's a pitcher at a mound, and we're asked to find out if the pitch meets the maximum height requirement, which is between 1.8 and 3.7 meters, and to find the height of the ball as it reaches the batter. Number 10 is similar. There's at halftime football show, there's souvenir balls that get thrown at the spectators, and we're just supposed to find if the balls are going to land between point B and point C, and what the velocity needs to be thrown to find that. Number 11, there was just a human centrifuge, and it's used to simulate space shuttle conditions, and we're just using a equals v squared over r to solve. 12 is there's an airplane flying at a constant speed. It makes a horizontal turn, and we're trying to find out if it'll meet its structural specifications doing so. Number 13, at the bottom of a loop in a vertical plane, an airplane has a horizontal velocity of 315 miles per hour, and there's a radar a certain distance away, and we're supposed to find the recorded values of r dot, r double dot, theta dot, and theta double dot for this specific instance in time. And then 14 is just another simple pulley problem. Other efforts, I went through some of the physics review videos. I clicked on the ones that I felt like I didn't know quite as much as I'd want to know about, and I watched through those. And a summary of the material is just the laws of motion, coordinate systems, coupled systems, along with the relations between x, v, and a, as well as the kinematic equations and a couple other odds and ends.